guys, are you taking the SAT soon and wondering how you can completely crush the math section? Well, that's what we're going to talk about in this video. Before I get started, I want to tell you that we have an awesome SAT prep course that we are designing right now. It's going to be hours upon hours of video prep with me, sharing all the things that I share with my private students to help them get the best scores possible. So if you're wanting to get in on all those SAT secrets, definitely stay tuned at SupertutorTV.com/subscribe to find out when that course drops very soon. We also already have the best ACT prep course ever, so if you're prepping for the ACT as well, definitely go check that out at our website. Okay, let's get into some hard SAT problems. The first one I'm going to start with, so I'm going to pull these from official SAT prep tests that are available as practice tests from the College Board and Khan Academy. So you can find these online at the College Board, or you can find them on a resources page at SupertutorTV.com/resources. I'm going to be pulling from test 3 and test 5. So let's get started. We're going to do question 13, which is kind of nasty and kind of ugly, and it falls under the category of what I would call polynomial problems. So one idea that I want to convey to you guys in terms of some of the hardest questions on this test is that some of them fall under this category of polynomials. And what do I mean by that? I mean that you have to understand that like long division is on the table. The equation 24x squared plus 25x minus 47 over ax minus 2 equals negative 8x minus 3 minus 53 over ax minus 2 is true for all values of x does not equal 2 over a, where a is a constant. What is the value of a? So when I read this whole thing, the first thing that I'm going to tell you guys is usually when you have something like this is just to prevent the situation when a denominator is 0. That's just their insurance plan so that you don't worry about that weird little case, okay? So I'm not going to worry about that too much. I'm pretty sure that's what that is. It's almost always what that kind of a piece is. And I'm just going to focus on how do I solve this down for a. And I know at first it might seem really ugly and terrible, but if you figure out what's going on, it's going to be a little bit easier to unpack. So here's what's going on. We have this piece here. It's divided by something. I get something like this. What I want you guys to recognize is whenever you see something like this, you have an x term, you have then like an integer value of some sort, something that's just a plain old number or constant, and then you have minus this, and you have like this fractional piece. This is the answer to a long division problem, right? So that's what this is about. This is polynomial long division, quote unquote. But doing this as polynomial long division is going to be really hard, right? Because that would require me to go like this, right? I would have 24x squared plus 25x minus 47. So I would do something like this. And I would say this goes into this how many times? Well, look, I know what that is. That's actually negative 8x, and then this is going to be minus 3. So you can see how one way I could do this is I could set up kind of the long division setup, and then I could multiply this out and write the stuff down and see kind of what I get, right? So that's one way I could approach it. But I'm going to approach it a little bit differently because I think it's going to be a little bit easier. But this at least tells me kind of what the setup is, that that's kind of what's going on. So you can see how I can use these little clues to figure stuff out. And I could have tried to step through that, right? I could have used what I know about long division and multiplied things out, but I think that might be a little bit nappy. So here's what I actually am going to do. I'm going to try to clear this fraction and move it over here. And I think that's going to be a cleaner route, okay? So we're going to have 24x squared plus 25x minus 47 equals, and now like I said, I'm going to clear the fraction. I'm going to do that by multiplying this right-hand side of the equation by ax minus 2. So when I do that, when I multiply this whole thing times ax minus 2, what happens is this is going to distribute to that, and to this. When it distributes to this piece, I just get negative 53. So I'm going to write negative 53 right there. And then this piece, negative 8x minus 3, I'm going to just put like this, and then I can FOIL that actually. I could have rainbowed it, if you guys know what rainbowing looks like. I could have done this piece times the negative 8x, this thing times the negative 3, right? This thing times this. I could have rainbowed it. This and this are going to give you the same answer. So if this confused you, just do it that way, and you're totally going to be cool. In any case, what do we get? We get negative 8ax squared plus 16x minus 3ax And then we have this, which is plus 6 minus 53. And you can see that's what I get here. This times this is this times that is that, positive 16x. This times this is this, and this times that is that. So however you do it, if you want to FOIL it, if you see it as the FOIL, if you want to distribute it like the rainbow. But in any case, what I get is this big ugly thing is equal to this up top, right? This 24x squared. So now what I do is I like to play a game that I call matchy-matchy. What is matchy-matchy? Matchy-matchy occurs when we line up all of our x squared terms together with our x squared terms down here. And in doing so, I can create like sidebar equations. So this has to equal this in my matchy-matchy game. So I can write down 24x squared equals negative 8ax squared. And aha, now I can solve for a. Do you see that? Because my x squareds are going to cancel. Then I get 24 equals negative 8a. And then that means that negative 3 equals a, and I'm done. Now, if I wanted to, I could continue down this path and I could continue to match things up and double check everything. Like that 25x, for example, is going to equal 16x minus 3ax. So here, oops, this is 25x. So I can see that 9x is going to equal negative 3ax. And again, you see here, I can solve for a and I get 9 equals negative 3a, or a equals negative 3 one more time, right? I get the same answer. And occasionally, if it says no solution or something like that, I can't actually stop at the first matchy-matchy. I literally have to match up everything. So that's a good thing to know as well. In any case, you can see how the second piece here is going to be equivalent to that, and then how 6 minus 53 has to equal negative 47, which it does. So this is just sort of a moot point. But you can see how I can play matchy-matchy. I can create an equation here, create an equation there, and then I can solve down for a. Ta-da! Hardest problem number 1. Okay, let's move on. The next problem that we're going to do is from practice test 5. Okay, 15. Alan drives an average of 100 miles each week. His car can travel an average of 25 miles per gallon of gasoline. Alan would like to reduce his weekly expenditure on gasoline by $5. So he wants to save, he gets 25 miles per gallon. He drives 100 miles each week. So instantly I can see that, and I know if he has 100 miles, right? This is 100 miles. I sometimes like to draw pictures and just cut them up. And he gets 25 miles per gallon. I can see visually how many gallons he uses, right? 25 miles, 25 miles, 25 miles. This is this times 4, right? And that's how much he gets for 1 gallon, right? So this is 1 gallon, 2 gallons, 3 gallons, 4 gallons. So I'm just drawing pictures to understand this. I can also do it with math, but I love pictures because they're easy to understand. How do I get to the gallons in another way? Well, the other way I do it is something called dimensional analysis. Okay, let's talk about how dimensional analysis works. I look at what I have. Here I have miles, right? I look at what rates I have. Whenever I have per is a rate. Here's what's cool about rates. You can always flip them upside down. And here's what you do to use a rate to convert stuff. If I have this and this has miles per gallon in it, and this has miles, and I want to convert it to gallons, all I have to do is get the miles to cancel. So here's how I do that. I set up my 100 miles, what I start with, okay? This I'm going to flip. Remember how I said conversion factors, you can always flip. So I get 1 gallon over 25 miles, okay? So we have 25 miles, and I know it says 25 miles per gallon, but we can flip that upside down, and then look what happens. I can get my miles to cancel. So this is the goal, is you want to set it up so these things cancel. This is a thing called dimensional analysis. So the principles are, whenever I have per, this is a rate. I write down my rate. I understand that whenever I have a rate, I can always flip it upside down if I need to. Then I look at what I have, and then I look at what I need. What do I need? Probably I want to get gallons out of this, right? I don't actually know what I need yet, but I know that I can convert this into more information. So I'm kind of doing this one piece at a time and doing that as I go. That might get me into trouble eventually, but I'm trying to wrap my brain around this problem, and this is my best bet, I feel like, right now. So I get the miles cancel, and I do 100 divided by 25 equals 4 gallons. This is the same output as I get by drawing it out, just trying to wrap my brain around it. If pictures work for you, heck, use pictures, that's fine, because the logic works. If that doesn't work, remember, dimensional analysis always works, and it's a detective game. You look at your per, You look at what you have, and then you set it up to get the thing to cancel. And remember, you can always flip this upside down if you need to, which is exactly what we need to do. So I get 100 divided by 25 equals 4 gallons. So here's the deal. He's buying 4 gallons of gas a week. He wants to reduce his weekly expenditure on gas by $5. We're going to assume that gas costs $4 per gallon. So now I'm going to just take this 4 gallons and I'm going to run with it, okay? So I know he buys 4 gallons of gas a week on average, okay? I'm going to assume that gas is $4 per gallon, right? So how much is he spending? Well, this is easy. $4 per 1 gallon. Remember, all of these pers mean divide. You can set this up as a ratio of sorts, as a conversion factor, as I like to call it. If I multiply this times what? I get rid of the gallons, times gallons. You see that? So when we have gallons on the bottom, we can put gallons here, and then they will cancel. So I buy 4 gallons a week. I pay $4 a gallon. Look at how this works. That's $16 a week on gas. So he's spending $16 a week on gas. Assuming gas costs that, what equation can Alan use to determine how many fewer average miles he should drive each week? So we want to convert all of this into miles per week, but I'm not going to start there, okay, because that's confusing. What I actually have related right now is gallons and dollars. So here's my goal. I know I have dollars to gallons. I can do a conversion there. I want to save $5, right? So I can convert $5 into a certain number of gallons he needs to save. Then I want to take the gallons he wants to save and convert that into how many miles less he has to drive, right? Because that's where I see my daisy chain. Do you see? I have, and I'm just going to write down all my rates here. I have $4 per 1 gallon, okay? So I have dollars to gallons, that's a conversion I have. Then I have miles per gallon, right? I have 25 miles per 1 gallon. You see that? That's another conversion factor. So this converts dollars to gallons. This converts gallons to miles. Are you with me? I can write down all my conversion factors, and I'm going to play a hopscotch game of flipping these upside down to get stuff to cancel to get to my end game, okay? So I know he's spending $16 a week on gas. I want to know, assuming gas is $4 per gallon, what can he determine how many fewer average miles he should drive each week? But I actually just want to know what is his reduction. And I can do that just by using the 5, okay? So here's how we're going to do that. I'm going to erase some of this stuff. So here's what I have. I know he wants to cut down $5. So if $5 is the cut down amount in dollars, I want to figure out, and I have these ideas here, and this is just me starting to understand the problem. But I know this is my cut down amount. I want to cut it down by $5. I want to convert $5 into the cut down amount in money. I want to then make that the cut down amount in gallons. And then I want to go to the cut down amount that he has to do in miles. Notice it doesn't say how many miles should he be driving instead. If it did, I would take 100 miles and subtract the miles, right? Notice it doesn't say how many fewer gallons does he need. That would be 4 gallons minus whatever he actually uses. You get what I'm saying? So the cut down in gallons, this is also a little bit of a TMI problem, like meaning they throw all this stuff at you. I'm trying to wrap my head around what everything means, but at the same time, I may have like wasted some time in there because I actually, when I get to the bottom, I figure out actually what I need is just how many fewer does he need to drive. Okay, so here's how we're going to do this. This is the cut down amount in dollars. I want to convert dollars to gallons. Here's how I convert dollars to gallons. $4 for every 1 gallon. I need dollars on the bottom because I need the dollars to cancel. So I have 1 gallon. So you guys see how this works? I do this times this, and then my dollars cancel. You see that? And then I get 5. This will make my dollars cancel. Now I'm going to multiply this. I want to cut down how much cut down in miles. I want my gallons to cancel. I want gallons on the bottom, and I want miles on the top. Okay, so I want miles is 25, and this is just a dimensional analysis problem. I know this hurts your brains, but I want to take $5, which is my reduction in cash, and I want to see how many is that in miles. I do this by setting up my rates, per means divide, flipping them as necessary to get the things to cancel that I need to cancel. I want my gallons to cancel. You see gallons and gallons, and then I'm going to be left with the miles, okay? So here we go, 5 divided by 4, and I can write this out, 5 times 1 times 25, all over 4. My dollars cancel, my gallons cancel, and this will give me miles. And that is 5 times 25 over 4 equals M. So now here's the deal. I did it this way, they did it that way. You guys see what I mean? So I have 5 times 25 over 4 equals M. They have M next to a fraction. So I need to make this look like this. So what I'm going to do is I'm going to multiply both sides by 4, and I get 4M equals 5 times 25. Okay? Now I get this, and I'm looking to try to make this, it looks like I have to have a 25 on this side. I'm going to divide that by 25, and I get 5. Okay, so that's the right one. So that's how I do this with dimensional analysis. I know it was kind of confusing, okay? That's all I'm going to show you for today. So there are 2 problems that are really hard SAT math problems. I hope you guys found this helpful. If so, please give this a thumbs up. Subscribe to our channel if you haven't already. We have lots more SAT and ACT prep tips as well as college admissions advice. So plug in, tune in, and we'll see you guys next time. Thanks for watching. Bye-bye.